Hello, welcome back. Here is Ali Talabi, and this is our last lesson from Module 8. Don't forget just to follow us and the wrap-up session for this module as well, which I'm going to review questions and provide you some hints. Also, I'm going just to show you how to use your financial calculator to find NPV and IRR in the wrap-up session. But for now, I'm just going to talk about problems in capital budgeting. One of the most major common problems in capital budgeting is when you have two different projects or two different equipments and they have different lives. So one, for example, can work for 5 years, another can work for 2 years. The question here is how you can compare those. Is it possible to use the NPV or other criteria which we already mentioned, or we need just to make some adjustment? So these problems are known as a replacement and project duration problems. And I'm going to provide you some examples for each, and I'm going to show you the concept of EAC, which is actually equivalent annual cost. So let's start our lesson. So let's look at this example. You have an old machine which still it's working for and it's good to go for another 2 years, and you can buy a new machine which is doing the same job, same function, but it lasts longer for 5 years. Now the question here is, should you go with this replacement decision, or you should just stay with the old machine? So can we use the NPV for this project just to make the right decision? Another example is when you're talking about two new equipment. So you need to, for example, use a specific component. You need equipment, but you have two options. Again, the problem here is one lasts longer, one is the shorter one. Which one you will choose, and can you use NPV to decide? So in this case, when projects they have different lives, we cannot use NPV directly. So we have to make some adjustment to the NPV, and based on that, we need to generate something which is called equivalent annual cost, or EAC. The EAC is actually is providing you the cost per period with the same NPV as the cost of buying and operating the machine. What does it mean? It means you are generating or creating a new set of cash flows in which is equivalent to one period cash flow. Now, if you can resize the cash flows, it's for 2 years, 5 years, 10 years, doesn't matter, and just fitting to just 1 year period, now you can compare apple with apples, because you can say, okay, this is 1 year, this is 1 year, how much cash flow I'm generating, or how much money I need to invest, or what is the cash outflow. Now you are comparing these two. You're talking about 2 year versus 5 year type of project, so it's not doable to compare. So I'm going to explain why the examples, how we can actually calculate the EAC. Let's look at this example. Again, the first example, which is called replacement problem, it's about the old machine. So you have the machine which costs you $12,000 per year to operate, or you can go and buy a new one which costs you $25,000 to buy, and since it is more efficient, it is just costing you $8,000 per year to operate. And for sure, it is a longer one. So this one works for 5 years. So the new one works for 5 years. However, the current machine, which is the old one, it just works for 2 years. And for sure, you have different cash flows. So the question here is, should we go ahead and replace the old machine, or should we stay with the current one? And let's assume the required return in this case is 6%. So we can use this to discount all the cash flows. So we can go ahead and calculate the NPV of the both machines. So when we calculate the NPV for these two machines, we see for the old machine, the NPV at 6% is 22. For sure, it is negative because it's just about the cost. And for new machine is 58.7 negative. Maybe you say, so we'll go with old machine because you need to pay less, or the net present value is less negative for this old machine. But actually, this is not true. Why? Because we learned that the old machine just works for 2 years, the new machine works for 5 years. So you cannot compare these two machines because the lives of these projects are different. So we need to generate equivalent annual cost for the new machine as well. We want just to generate the cash flow, which gives the same net present value, which is 58.7 in this case. So how we do that? The point here is, in this case, it's much easier to use your financial calculator. Again, if you go back to your financial calculator, we talk about the time value of money and 5 major variables which are in your calculator. So that's NI per year, PV, PMT, and future value. So you are generating the same present value, which means the present value should be 58.7 here. So you want just to have the same present value. And for sure, this is about 5-year machine, so N is 5. The appropriate discount rate here is 6%. The question is given. Your goal here is to generate the equivalent payment, and the future value should be 0. So if you hit these numbers in your calculator, you will see the equivalent payment or the equivalent annual cost in this case is 13.93. So in other words, if you use the positive present value, it becomes negative. If you use the negative, it becomes positive. So it should be minus 13.93. So now you can compare this equivalent cost or payment with that $12 which you had for the old machine. So which one costs you less? For sure, 12 is less than 13.93. So since the EAC for the old machine is lower, you will stay with the old machine. You don't proceed with the decision. So you don't go with the replacement decision. So don't go with the NPV. NPV is misleading, is not providing the full information in this case. So you have to go one extra step. Yes, we are using the NPV to find the present value. However, we need just to generate the equivalent cost by using the financial calculator. Another issue which we have is similar problem, but when you are going just to buy new equipment or new machines. So let's assume that you have two options. Machines A and B are doing the same job. However, you see the machine A is actually costing you more, $15,000, and it lasts longer, 3 years. And also you need to pay $4,000 for the operation. However, machine B is actually costing you less, but it lasts shorter, but because it's less efficient, you have to pay more on annual basis for maintenance. So which machine you need to use? Similar argument in the first step, find the NPV and then generate the equivalent annual cost, which based on the financial calculator is your payment. So let's do this. So I calculated the NPV for machine A. As you see, it is 25,690 based on these cash flows, and the discount rate is 6%. And for machine B is 21,000. So if you just go with the NPV, you will choose machine B because it's saying, you know what, it costs me based on the net present value, it costs me less. I will choose that. However, we cannot compare these two projects. What we do, we'll go with the equivalent annual cost. So I'm using my financial calculator. You have all the numbers here. So for machine A, your N here is 3. It's 3-year project. Your I is 6. The present value is 2569. The future value is 0. You calculate the payment. So that's what we do for machine B as well. We do the same thing for machine A. So let's do this for both machines to see what is the equivalent payment. So for machine A, so 3N 6I 25,690 present value. Future value is 0. I'm computing the payment. So for machine A, the number I have here for the payment is 9,611. So the equivalent annual cost is 9,611, and for sure that's a kind of negative number. For machine B, I'm doing the same thing. So N2, I is 6%. 21,000 is the present value, FV0, you compute the payment, which is $11,454. Now, which one is giving you lower EAC? You want just to go with the lower cost. You're right, machine A. So you will choose machine A over machine B. So you notice that the NPV is giving us machine B, EAC is leading us to machine A. So you always prefer EAC when the lives of projects are not same. So in this case, the equivalent annual cost 9,611 is for machine A is better than 11,454 for machine B. So that's how you choose projects. So that's it for today. Thank you very much. I'm going just to wrap up the session with some questions, and also as I promised, next lesson I'm going just to show you how to use your financial calculator to calculate NPV and IRR. Till that time, have a wonderful day. Take care. Talk to you soon. Here is Ali Talabi.